sweet stuff. This is super cool. Okay, how far have you guys gotten in lecture yet?
We covered a little bit of, I don't know what class you're in.
We haven't started muscle yet. I think that's next
If I
class.
said DHPR, you say... Okay, good. Now I know where to teach it. Dihydropyridine, ryanodine? Nothing?
Wait,
Okay.
who's your teacher?
Anderson?
Oh wait, I have Anderson too, so we're at the same point.
Okay, perfect. Are you in the same class?
I don't know.
9 a.m. Monday, Wednesday, Friday? Yep, same class.
Why am I drawing sodium in the cell? The person is now dead. Okay, we're drawing this. We could be drawing a muscle cell, or we could be drawing a nerve cell. Okay, you follow me? So we draw this real simply, and this is how we are kind of looking at this cell.
I have a quick question.
Yeah.
So do action potentials only happen in like muscle and nervous cells, or do they happen like all throughout the body?
I think mostly muscle and nerves. That's what you need it, yeah. Well, happens in your ears, happens in your eyes, your nose, your tongue. So, not necessarily muscles. Well, those are
Oh, but
nerves,
those
so
are
yeah,
nerves,
it's
so
nerves,
yeah.
so yeah. Muscles and nerves, pretty much.
Okay, because like I wasn't sure. I
Yeah.
assumed it, because it wouldn't happen in like bone or something. Because
Nope.
no, it wouldn't happen in bone. That's just not possible.
Wouldn't need it.
Yeah, and so I figured it was just those two, but I want to make sure.
Yeah. So how we're looking at this, when we draw this, we're drawing it like it's coming this way. Does that make sense? So we're going to draw a 3D version of it.
Oh, okay.
Kind of like that. Does that make sense?
Mm-hmm.
So what we're actually looking at,
It's like a cross section.
yeah, we're actually going to be focusing on this.
Soma.
Yeah, nerve cell, right? So this is where we're going to be seeing these action potentials occur. So we're just taking this circle picture, we're transferring it over to here. Easy enough, different shape?
Yeah.
Okay. So we've learned about what sodium and potassium do to a cell, right? Sodium excites the cell, and potassium inhibits the cell, or inhibits action potentials. Do you guys understand why?
Is that because when potassium rushes out, it makes it less positive and further away from zero, whereas like sodium, when sodium rushes in, because it doesn't rush out like necessarily, because there's not, it's a concentration gradient, so the sodium will rush in, which makes it more positive, which helps it get to that action potential.
Exactly. So we've got this, which is going to help depolarize, and this is going to help hyperpolarize.
I was totally going to ask you that question, and then when I started saying it, I was like, oh my goodness, I just answered it for myself.
And the interesting thing is, with a lot of net and phys, you could actually answer the question yourself by just saying like, well, this just makes sense for this to happen. Which is kind of cool when you're taking your test and you're like, oh wait, I could actually figure this out probably.
I just draw it. I just draw it all out. Like with homeostasis, I was like, okay, I need my stimulus and then my receptor, and like I totally did that. So whenever there were questions about homeostasis, I could like figure out what the answer was. It was so much easier.
Oh yeah, it's the way to do it. Okay, so we have two different types of summation. You guys tell me what those are? You guys gone over summation yet?
Yes, it's when you add up the action potentials, like the graded potentials / local potentials. And you have like the temporal, and then there's another one.
Temporal and spatial.
That's the other one.
So we talk temporal, we're talking time and frequency.
And those ones happen at like the same time. Oh, I know what spatial is now.
And we're talking spatial, we're talking more like location and maybe number. So yeah, these are both taking place at the same time. It's just how, it's really like a race. Who's going to win? Okay, for temporal, you're gonna have a whole bunch of different receptors out here on the soma. And I'm gonna draw different receptors too. Okay. Let me know if I'm going too quick. We good?
Wait, what did you just draw?
I just drew two different receptors. So this receptor that's like this, we'll just say that's sodium. And the one that's like this, potassium. That makes sense? Solid is sodium, blank is potassium. So just based off a number of receptors there, would we say temporal or spatial is going to win? As far as summation goes.
Spatial?
Spatial, why?
Because there are more of them. They may be in like, not right next to each other. Well, they kind of are right next to each other. But like, there's a lot more of them compared to the potassium.
Yeah, so there's
So it's a better chance of getting set off by
6 of
potassium.
these or so, and about 2 of these. So it's more likely that you're going to have more sodium rushing in this example. Make sense? And then, if we did this, which one's most likely to win?
I'm still sticking with my answer.
Spatial? Okay.
You guys
No.
no idea.
Yeah, it'd probably be spatial because location. These guys are in a good location, right? You guys ever have those summers where you're like, last one in the pool wins, and your friend's like already at the pool, he's like, all right, and he just jumps in. That's what these guys are doing. They can just let potassium leak in right here, and they've got a head start compared to all these guys. Because what they're trying to reach is the axon helix right here. Does that make sense? They're real close to it. And this is where you have a lot of voltage gated sodium channels. They're super, super numerous right there. There's a ton of them. And so if an action potential is able to occur and reach this point, it's money. Action potential is going to travel all the way down here to another nerve, to another nerve, to another nerve, to your muscle.
Wait, so the axon helix, what are you saying is there?
Voltage gated sodium channels.
Okay.
Which means a lot of sodium is going to rush in and the cell will depolarize, right? You follow along, Sunil?
Yeah.
That makes sense?
I'm just grasping the temporal and spatial, like why you said that.
Okay, we're going to spend some more time on it too, so
Okay.
if you do have any questions, let me know. So I'm going to give you an example of temporal summation. Erase these. Okay, so we have a channel here that's leaking. We'll just say there's an even number of receptors here, or channels. Let's say this is leaking potassium in, and it's letting 500 potassium in a second. Okay?
That's a lot of potassium.
And we're letting in, we got sodium over here. We'll just say it's at the same spot actually, like right here. Sodium, but this is only letting in 200 a second. Are we going to see more temporal or spatial summation? With just this scenario.
I'm going to say temporal,
Be temporal. Why?
because it's the frequency and the
We're
time.
just,
Like,
we're just looking at
you're
the
getting-
time and frequency, right?
Yeah, because you've got more coming in from potassium than sodium.
So the frequency is 500 and the time is per second.
However, is it only just that one that's open and then all the other sodium ones are open, or is it just those two that
We're just
are open?
imagining those two pretty much.
Okay,
Does that make sense?
because that would be a very different situation.
Yeah, so if on the test they said, you're seeing 500 potassium rush in a second and 500 sodium rush in per second. And the potassium wins because it has a greater number per second rushing into the cell. Is this temporal or spatial summation? And you would say temporal summation. Does that make sense? Okay, so now we'll change this up. We'll say these are potassium channels. We'd this having a big influence on spatial summation, right? Does that make sense? There's a lot more receptors for the sodium to rush in, and they're also in a lot better spot, right?
In comparison to,
In comparison to the potassium channels.
okay.
So if they're coming in right here, you're gonna have a bunch of potassium there, whereas you'd see a whole bunch of sodium down here. And where are they trying to get to? The axon helix. See how sodium's in a better spot?
Because it's closer to the axon helix,
Yeah, it just entered in a better spot.
and there are more of them.
Yeah.
Okay.
Okay, any questions?
Is this something they'd like draw out and show you, or is it like written description, this is here and this is there? What
You
is it?
might see a drawing like that. I don't remember though, but I think it's just using words.
I think most of it's
It'll
words. They have
say-
like some diagrams, but I was
A
just
lot
like.
of the sodium receptors are right next to the axon helix. Are you gonna more see spatial summation or temporal summation as a result? Spatial, yeah. That make sense?
But if they actually use numbers in it, they increase every time the temporal.
Usually, unless they're just talking about the number of channels.